All right, and good morning, everybody. This is Jeremiah, and we have a wonderful webinar all ready for you today. Getting back into, we've noticed it's been a while since we've done anything on irrigation, so this is going to be a great little kickoff for queuing back up that. And before I forget, happy Halloween, of course. I hope everybody is wearing a costume that is original and awesome. Um, Anyway, we have a webinar on the unique challenges of designing or irrigating small spaces. So we have Chris and Rob from Hunter Industries. Chris has been with Hunter for 13 years. He's their spec manager. And Rob is the product manager for micro irrigation products. So it's a good duo for this. Very informative. And I see we've got a pretty packed house, so hellos across the board. A very high uptick of university attendees. So hello to all of you and all the universities chiming in. It's going to be a very informative webinar, some really good content here. And so I think without any much more of my blabbering, I'm going to go ahead and throw this over to Chris. So Chris, take it away.
Hey there, guys. Happy Halloween. We wanted to kind of get back to the basics, some of the design principles. And one of the things we get asked for a lot out in specifiers offices is, hey, we've been designing big systems for years, and now with things like multifamily housing, shopping centers, these tighter areas, we're starting to get into more of a challenge with putting sprinklers in small spaces and really doing it efficiently. So we kind of came to the idea maybe we should put together a series of slides on how some irrigations in the past have been done, and ways that we think you could use different tools to maybe either do them differently or some examples of some well done installations. So I'd like to talk about some areas that you might typically find a small space irrigation. Lots of shrub beds, there's tons of small spaces out there. Your gardens, hedges are a really popular area where you got a really narrow space. Pots, parking medians, really just a lot of small areas. And now with these street medians, we're starting to see a request for small turf areas, narrow turf areas. So we'll talk about that a little bit. If you had to do turf, and obviously we're doing a lot less turf now, but green roofs and green walls, we're going to touch on that too, but that's got a lot of information in it. So typically places I see these are, most of the slides are taken from either residential spaces or HOAs. Shopping centers tend to be the worst. Of course, schools. There's a difference with schools and commercial space. Now you gotta look at how durable are the products that you're going to be specifying, and then of course street medians. Sometimes with street medians we can get away with doing inline drip tubing, and then other public agencies will say, well, I don't want to have to get out there to check it as much. So can you give me something different? And we're going to give you some other solutions here as well. I think the biggest challenge that people ask, designers are fighting with is how do I prevent overspray? And if I have a system that is, that has high application rates, how am I going to control the water so it doesn't leave the site, whether it runoff or you have just naturally high application rates with small space irrigation in general. Then curved edges. Every project has curved edges, it seems like nowadays. And then the other thing is, when you get socked into these small planter areas, I'm going to show you a few slides that you get this heat island effect where the hardscape heats up and starts radiating heat, and that can actually wick water out of your planter area. So we'll talk about that. Drainage issues, oftentimes, the water from the surrounding hardscape starts to collect in your small landscape planter area. So you got to make sure we got good drainage, and then how do we irrigate off of that? Lots of equipment, because when you get into small spaces, you don't really have room, but you tend to have a more dense application of heads, so you end up having to kind of fit this stuff into small spaces, and that can be tough. Of course, foot traffic, get lots of people crossing through small spaces. And then one of the things that I think that's been brought up a lot is, just general understanding, where the sun's going to be and how to irrigate for those shadows, because oftentimes those can get you. So, good design practices with plant types and, proper application rates, I think, are important. And so the things that you want to look at first, I mean, your local ordinances. Here in California, we have AB 1881, which typically dictates where sprinklers and how we can design irrigation systems, for different projects. And then you start looking at hydrozones, your plant water needs, and then you got to have a realistic budget for your client as to how many valves can we actually have. What's the project going to be when it's done? Is it a small 2-apartment complex that we're designing, but it has 48 valves just because we have all these shade areas and stuff? So what's the budget that we're going to have, and how can we address that? Of course, water pressure, water source, and filtration and regulation, something that you don't want to forget about too with these small areas, because usually we're either doing small emission points, and high pressure with a small emission can cause issues, and as well as clogging of emitters and small bubbler type of things. And then defensible design. The last thing about defensible design, I think, is something that we all look at as designers. What's this project going to look like down the road, and how can I make it as bulletproof and simple for the maintenance contractor as possible? And I think those are the key elements on some of these systems that we really got to take a look at. And then looking long term, what's the mature plant size going to be? Do I need to do an extra row of heads down the middle because the mature shrubs are going to block the heads shooting in from the outside? And then the big decision is, do we go overhead, with more of a spray or a rotator, or do we go with a drip installation? That once we get to the drip installation, are we going to go an inline emitter tubing, point source emitter type of thing, or do we want to go subsurface? And so those are some of the other things we're going to talk about today. But I think the big thing is not only with the defensible design concept, but also having a specific, clear written notes and installation details showing exactly where you want this stuff installed, so that the contractors can bid it appropriately, and that what you're going to get for your client at the end of the project. And things as simple as we do subsurface. That's going to be one of the things we're going to cover. We got to call out a temporary irrigation system if we need one, and that way it's bid, it's put on the legend clearly, and contractors can see it. So, kind of getting into some of these spaces, it's kind of funny. This is a slide Rob sent us, and I think everybody's taking it to the extreme these days, but you really do have small spaces. And in any commercial project you come across, you're going to find these weird corners of a shopping center, where you got a triangle planter area, and how do you go about irrigating that? So this one here was a shopping center designed with sprays and bubblers, and although sprays are becoming a little bit more controversial, I think we're starting to see bubblers as still an option, a viable option. But you got to look at the traffic patterns in some of these areas. And this shopping center actually happened to have a really small triangle area here, and there was mixed sun exposure. You could see the buildings kind of shadowing some of the planters in back. And then you got this small full sun area right there in the traffic pattern. So, those are the things you got to kind of look at, is how durable does my system need to be when we're designing this. We have irrigating pots. Pots are always a challenge. Self-watering containers are sometimes ideal. A lot of times you'll see 1/2-inch micro tubing, or 1/4-inch distribution tubing would be another option. A little laser line coil of tubing around the root ball at the top of the planter works well. But if you don't have an irrigation source to your planting, pots and containers, this is ultimately what ends up happening, and it really just ends up costing your client more in the long run. And the other thing is, I think you kind of risk losing plant material due to drying out, essentially. This was a recently installed project, and this one's one of those small little parking island medians here. This was done really well. This actually used on-grade drip installation below drip irrigation below bark mulch, and I think it was a great choice for the tall grasses because, you know, it was a spray head. They might be getting obstructed by the grasses, and there's no runoff and no plant obstruction here. So this is a really good installation. This is another one. I couldn't help this. I actually tripped getting out of my car on this planter. So I had to take a picture of it because it really is the extreme of what we have to irrigate. And in this case, I think they used bubblers in the medium, which I think is a good choice with the bubblers because people are going to be cutting through this thing, getting in and out of their cars. But you know, you want to look at a bubbler. You know, if you're gonna install them, that retracts completely, so the bubbler and the irrigation device can't get kicked or tripped on. This is another example of a raised planter. Raised planters can be a little bit of a challenge as well. They used, in this particular example, 5-foot center strip bubblers, which are actually kind of like a spray, but it goes right down the middle of the planter, and it was a pretty robust installation on this particular one. Also, you know, drip inline emitter tubing would have been a good choice there as well. You know, and then you get into the sun exposure. You've got a building that is partially blocking your sun, so it's not directly, you know, south facing. It's not directly north facing. Where is the sun going to be? And some of these planters, you could see some of the ground covers kind of didn't make it because they had to irrigate, you know, close to the building. They didn't want too much water close to the building, so in some of these small areas, you may have two different microclimates, and the point here is you might want to have some irrigation directly, you know, adjacent to the building, and then, you know, further out in areas where you might have full sun, you might want to, you know, split that zone in half so that you can irrigate into the shadows. Trying to figure out where the shadows are going to be is always the important thing on the front end. How do you know before the building's built and, you know, where things are going to be? There's some apps you can get. That one of the apps I like is called Sunseeker. You can actually go with a mapping image from above on your mobile device and see exactly where the project's going to lay out and what the summer, winter solstice, you know, the axis of the sun might look like. So it's kind of neat, you know, to kind of get that. But that's really the biggest maintenance challenge is trying to irrigate these things when you only have one zone of irrigation and part of it's in the shade and part of it's in the sun. So, you know, breaking it up is always good. Again, going back to that heat island effect, you know, you get these parking lots where it starts radiating a lot of heat, and all that you know, radiant heat's going to start to wick out some of the water in the planting medians, as well as, you know, in this particular example, there's almost as much utility space, you know, utilities and underground stuff as there is, you know, sprinkler space. And same thing here. You know, this was an example where, you know, going back to the previous slide, they did do some subsurface irrigation in here. This was subsurface turf. It's been installed about 10 years. And that's kind of working out okay. You don't see as much runoff. This was a spray installation where the plant material kind of grew up and obstructed the sprinklers, and then you ended up having a lot of runoff. And unfortunately, this is recycled water going in the storm drain. So this was a designer's dilemma from the first place. But the sprays probably weren't a good choice in here. I might have gone with you know, a bubbler or possibly an inline tubing. You know, the big thing right now with a lot of the bigger clients is they want their landscapes to perform. So plant health is absolutely critical, and how these plants, they want these drought-tolerant plants to look good, you know, year-round, or you got to maintain that constant curb appeal. So choosing your irrigation based upon the optimal plant health and how these plants want to be irrigated, that can take effect. That could be a big factor in your decision. In this particular case, a large burger chain they had sprays and drip, you know, mixed in on their systems, and they kind of started looking at going more with a subsurface irrigation approach. So that's kind of just the intro to our presentation. Jeremy, do we have any questions here so far? Shemaya?
Nope, no questions so far. It's looking great, but I will just reminding people, do feel free to type some questions into the question box, and if we, I'll always be sure to type and answer back, but I'll get Chris to answer anything that needs to be done live. But yeah, let's move on.
Great. So, okay, well, going into a few more of the solutions, we're going to kind of start with overhead irrigation and kind of migrate our way into some of the other micro approaches, and then Rob will take over. But you know, our toolbox here of design stuff is getting bigger as manufacturers' technology continues to come online. I think it's important to stay connected with what's coming out, and you know, really test these products to see how they might work on our future designs. And you know, we've always had, you know, short radius sprays. Now we have some solutions with short radius rotator nozzles. Of course, bubblers have been around for a long time. You know, micro sprays, the tree deep root watering systems. You know, and then of course you get down into your emitter line and point source solutions. So, you know, some simple overhead solutions, yeah, they haven't always been the best. You know, I don't think having as much spray in your walkways and hardscaped areas as you do in your landscape is definitely appropriate. I think the social acceptance of overspray is becoming less tolerant now, and I think we're starting to see these types of runoff situations as being a real challenge, and particularly for designers. But you know, when you're doing an overhead system with pop-ups and things that are going to stick out of the ground, I think it's really important to pay attention to detail as to where your heads are going to be in relationship to other stuff. Like for this example, there were no wheel stops specified, you know, on this project, and so the planter actually was in the path of the vehicles. And so I think you'll see that, you know, looking at your area, okay, we have a small narrow space, where do we put the heads? First of all, I think you're going to go back and see that some of these agencies are going to call for a 12 or 24-inch setback from the curb anyway, and so, you know, this particular example might not have been an issue. But then it's, you know, how wide is my area, and can I actually put in an overhead system anyway? So those are things to consider, and then of course, you know, where the traffic is going to be. Overhead, you know, sources like sprays, you have options down to the 2-foot radius. They tend to have a higher application rate, and sprays tend to have a little bit lower efficiency than some of the other technologies out there. But you know, be advised that if you are using short radius sprinklers, you tend to have, you know, anywhere from 2 inches to 7 inches an hour precip rate. And if you look at what that is compared to your soil intake rate, you might be putting it down faster than the soil can absorb it. So that's a real important thing for the maintenance personnel to understand, because they're going to need to cycle and soak those sprinklers. I would say that sprays are a pretty good choice for high traffic areas. If you're getting a lot of foot traffic, they retract, they're out of the way, they're pretty robust. But you know, the smaller the spray, the more susceptible they are to clogging. I'd also make mention of that too. You know, you've got 2 to 6 foot short radius options, some adjustable options, and these generally work pretty well if you have a small area. Maybe you're spraying in toward a planter bed and you're not worried about the, you know, overspray as much. I think when we get more into the high efficiency overhead, we're looking at, you know, low precipitation rate, slow application of water. The MP short radius was recently launched by Hunter Industries. We call it the MP800SR, and that stands for short radius. These would be mounted on a pop-up sprinkler or a riser mount sprinkler, and they rotate. If you've all seen a rotating sprinkler, an MP rotator, you're probably familiar with that. They tend to rotate and put out water very, very slow and controlled. So it's a good efficient way to put water down, and I think these are very robust because they flush themselves pretty good, so they don't tend to clog up, and then, you know, of course they'll retract out of the way of you know, any traffic. So one thing about the MP800, if you notice the precipitation rate on the MP800, one of the things that we were tasked with doing was designing a short radius solution, but we also went with a 0.8 precip rate on this particular model sprinkler. So your at 0.8 inches an hour, which is exactly double the precip rate of an MP traditional MP 1000 or MP 2000. So the good news is your runtime is going to be cut in half, overall runtime for your sprinkler system, because it's going to be a little bit higher application rate, but it's also still going to be under that 1 inch an hour precipitation rate or application rate that we would look for low volume. And then we get into these side strips, these narrow strips of turf. You got a 5 by 15, foot nozzle, or a 5 by 30 foot side strip. These are pretty great to eliminate runoff, because again, we're watering with a rotator, which is controlled irrigation, and it helps to eliminate the overspray as well. So you've got 5 by 30 foot side strips and 5 by 15 foot corner strips, and when you put these together, you get a nice rectangular watering pattern. And you can see, MP rotator's performance compared to conventional sprays with that heavy application of water. At the slide on the left is about an 8-minute watering time, and the slide on the right is about a 12-minute watering time on the MP rotator. But you still have very controlled, slow application of water. So we're trying to get it into the root zone without any water leaving the site. When we're using MP rotators, traditionally, these rotating nozzles like a 40 psi. That's what's optimal for the MP. The gray cap on the Pro Spray has a 40 psi indicator on top, and that means that the stem of the sprinkler is regulated to 40 psi. So you always have that consistent output. When you get down into the short radius, this is another note. If you're used to designing with MPs, traditionally you're going to have them on 40 psi, but when you're trying to get down below 9 feet, that 6-foot radius and completely throttled down, you're going to want to recommend and specify those on 30 psi pop-ups, so you can adjust it down to the minimum radius. So that's kind of all for the just overhead distribution of irrigation. Getting into bubbler technology, pop-up bubblers tend to be a good way to go. These are your traditional bubblers here. They're going to be riser mounted on a Schedule 80 riser. Traditionally, they're going to be above ground, so it's something that you'll see, and it's potentially a trip hazard, so you want to be careful that you put them in low traffic areas. But now we're in gallons per minute, so we're about a 1/4 gallon a minute to 2 gallons a minute, so it's a fairly high application rate, and you're going to want to do really short bursts of irrigation, short cycles on these to get the water in. And that's common with any bubbler nozzle, but bubblers are cool because they don't really put water out too far, and you can tuck them into small areas. So it's a good solution for high traffic areas. And even better with that note would be the type of bubblers that retract onto the pop-ups. And these MSBN nozzles, multi-stream bubbler nozzles, same flow rates. Again, you get directional 1/4 and 1/2 patterns as well, or there's the full circle patterns if you want kind of that umbrella-shaped watering pattern. But you can get them in various flow rates, and they're color-coded so you know what you're applying. What's nice about this is they can't be tampered with, so that's always going to be the same flow rate factory installed. And irrigating with these nozzles is kind of neat, because when it pops up, you can actually see it irrigating. You can see where that water pattern's going, and when it retracts, it's completely flush. So you could literally walk across this thing and not really know you stepped on a sprinkler if the sprinkler's at grade. So they're nice because they're directional, and you can kind of tuck them in. Other ones I've started to see a lot more on military installations where they're using these versus a point source 1/2-inch poly pipe. It's a pretty rugged installation. This one is installed in cobble, and again, it's just in a parking median, so they know they're going to be cutting through on that. And then some of these other strip areas where you're not quite a bubbler, I mentioned the center strip bubbler nozzles. This is kind of that bow tie watering pattern where it's a narrow strip of water about 2.5 feet wide with a 5-foot radius. So you space these things 5 feet on center in a linear planter bed. Again, it's more of a hard pipe installation. It's an overhead installation, but it's great because they retract, they're out of the way, and if you need to get the water to, kind of hydrate the foliage from the top, it's a good narrow space solution. And then of course we get into micro sprays. These are commonly used in small gardens, more of a residential application because you're using a 1/4-inch poly pipe to distribute the water from a source. But good little sprinklers. I've seen them used on green roofs too, and they actually work pretty well on green roofs because you can get them down to about 2 foot. But they are relatively susceptible to clogging, and you can just walk right up to them and adjust them. So you may not want that adjustability, or you may need that adjustability if you're doing your garden and want to be able to fine tune it. So again, more of the micro bubblers. These are definitely low traffic solutions, but they're very flexible. You can move it as the root ball grows and as the plants grow. So it's a good solution. So that being said, we've kind of covered the bubbler solutions. Is there any questions up to this point?
We did have a really good question, but on the valves, and so if this is a good time to address that really quickly, or maybe it's a little bit off topic, but sorry, there you go. Brandon was just saying that he's primarily having difficulty in finding valves that can handle these very low flows, and has a hard time splitting up the zones that are so small that it doesn't even have enough flow for the valve to function. Mm-hmm. And so if you have a product recommendation for that.
Yeah, I think that's a really good point. I do have a couple slides in here that talk about valves. And if you're going to a very small system with just a few heads on it, or very low flow bubbler or drip nozzles, you got to have a low flow valve. It means that the lower end of the range that the valve can perform, it can still close under low flows. I think that's really important, that you choose a valve, and I'm going to give you some examples of that in a minute. Even if you're just doing a couple of tree root watering systems like the slide we have here, if you only had one of those on a valve, you might be hard pressed to find a valve that's going to close at a 1/4 of a gallon a minute, for example, or half a gallon a minute. So I'm going to get to that in just a second. We've got a good slide on that as well. The deep root watering systems for trees and large shrub irrigation. Now this is something that you might consider if you're doing transplanted trees and you want to give them a chance to get that root ball nice and evenly wetted all the way deep into the soil. The other thing you want to do is provide an opportunity for oxygen and nutrients to get down into the root ball as well. And so these allow you that. Installs flush on grade. And it's great for parking medians and narrow little islands, planters where you don't have much space to put overhead sprinklers, but you got to get some water down into those root balls. One of the unique advantages with this particular system is that it has baffles inside of it, so it directs the water at various heights and stages of the root ball. And that's kind of a neat thing. But you really want to take a look at what your soils are. I mean, the soils really important as to how well that water is going to infiltrate and how deep it's going to go into the soil. You probably want to do at least 2 per tree or large shrub, and if not 3 on a equilateral triangle spacing. They have check valves in them as well, so that's kind of a nice thing if you're on a slope. And this is what they look like installed. You're putting them kind of at the edge of the root ball. If you're using a box tree or some sort of a transplanted tree, you're going to put it at the edge of that root ball and let it kind of soak in. However, what I've learned, from doing some of these street trees is that depending on different soils, you're probably better going with a dual-purpose system where you have the deep root watering system and then some sort of a supplemental overhead watering system to get that water from the top down. And whether it's a bubbler like we see on the slide to the right, or it's a ring of inline tubing, that's going to help you evenly distribute from the top all the way down. And another recommendation would be to put these on separate valves. You may have turf grass over the top of your strip island, like the slide that we saw before with the narrow strip of grass and the trees. So that turf grass water is going to supply water from the top, and then you're going to want the root watering below. But you want those to be on separate valves so you can control that and cut it off once the plant's mature. And then, of course, getting to your slide about the low flow valves, the commercial grade valves that we offer, in this particular case, it's an ICV valve, that has flows as low as a half a gallon per minute, and it'll go up to 15 gallons a minute. And anytime we're doing drip or bubbler type of systems, it's recommended that we use a filtration system. Even with a short radius MP rotator, because the filters are pretty tight on those MPs, I'd recommend a filter screen, about a 100 mesh filter screen. And typically on these zones, you know, when you have small spaces, you're going to want to pressure regulate, because a lot of times you got a big water source, high pressure going into a small area, so you want pressure regulation. And there's different ways to do that, different drip zone kits available on the market. You know, you want to make sure it fits in the valve box, and you know, it's kind of a package system. This comes out of the box pre-assembled this way in this particular model valve, but like the question that was brought up, you definitely want to make sure that that valve will close with whatever your minimum flow is for that small zone that you're designing. And now that we're into irrigation and micro, I'm going to go ahead and turn it over to Rob Kobaleski to discuss some of our micro products. So just a moment, here's Rob.
All right, hi everybody, appreciate it. When it comes to the point source emitters or drip irrigation in general, we have two different methods really that I'll just touch on quick. Point source is going to be using individual drip emitters. They will be centered around a plant. The objective is to water directly to the plant root system, to put down in gallons per hour basically a precise amount of water needed for the plant. As we move on to an emitter line section, that is more of a broadcast type of irrigating. We're irrigating the soil, assuming to some degree that we have some sort of dense planting or hedge or row of plants. So watering around the root zones, knowing that they're all spreading out and overlapping is important there. As far as point source emitters, the majority of those, the higher quality emitters, are going to be pressure compensating. So whether you have a pressure of 20 psi or 50 psi coming in, the emitters are going to put out about the same amount of flow. It compensates for those different pressures. So these emitters work sometimes through the use of a single smaller port to compensate for the pressure, and oftentimes they have a diaphragm in there that will go into place once the pressure is above, say, 8, 10, or 12 psi, something like that. All right. Emitters take many different shapes and sizes. An example here is that you may have barbed, self-piercing barbs on certain emitters. You may have 1032nd threads. So depending on somebody's design style or the way you like to do drip irrigation, you may have an emitter on top of, say, a flex riser with the 1032nd threaded. Or you may have a self-piercing barb. Well, that will be pierced right into a half-inch poly tubing, or it may have quarter-inch tubing leading up to it. Another method of doing that is a half-inch threaded type of emitter. You'll see these emitters out there as well. So it's going to be lower flow than, say, your standard bubbler. So if you have a quarter gallon per minute as a bubbler, but based on the soil type, let's say you have a clay soil in a small area, you need a lower flow, but you do have a Schedule 80 riser or something like that. A lower flow 1 gallon or 2 gallon emitter with half-inch threading might be the appropriate solution for that. One thing that we really appreciate is our emitters are made in the USA. A large amount of Hunter products are made in the USA. For when that topic comes up for different installations for certain jobs, that's an important note. All right, this gets to some of the fun stuff. When we're talking about small spaces, even sometimes some larger spaces. On-grade drip has been a product that's been used over many years, internationally and domestically. It's a regularly accepted product, and this is a good picture showing a grid layout. You can see near the top left of the screen there's a PVC header, and we'll talk about that a little bit throughout this portion. But a PVC header is a great way to stabilize a system, ensure that the spacing is accurate right from the start. So in this case, we might have, say, 18-inch lateral spacing between each of these lines. Let's say the emitter spacing is 18 inches. A PVC header will help ensure that we've done that from the start, and we can keep the consistency throughout the system. Some drip irrigation terms. We've got application rate. So typically with drip irrigation, from emitters, microsprays, and that, we're going to measure in gallons per hour. Once we get to emitter line, where we're laying water down on the soil, either on the surface or subsurface, which we'll talk about as well, we can convert to an application rate so we can compare to sprays. Self-flushing, a lot of emission devices in drip irrigation are self-flushing. What that means is we have small orifices, small parts. There's diaphragms in a lot of the components, so when a system first starts up, a lot of times it takes the pressure, it takes a little bit of time for that pressure to increase. It might be a few seconds or it might be a little longer, and during that period, it's common that the diaphragm has not slapped into place yet and started compensating, so that is a self-flushing period for a lot of emission devices. Root intrusion and physical root barrier. Most emitter lines, whether they're standard at grade or subsurface, they're going to have some form of protection against root intrusion, and a lot of times that is with physical root barrier or some other method. We talked about pressure compensation, and what's become very popular, particularly in the last, I would say, 5 to 10 years, is check valve emitter line. The check valve will maintain the pressure in the system. When the system is turned on, with that pressure already maintained, what you will allow your product to do is start emitting from each emitter at the same time. There's a little bit more consistency with the check valve emitter line than without it. Standard emitter lines, great for surface installation, hedgerows, gardens. There's consistent flows. It's also offered in 1/4 inch. Some of you may have seen 1/4 inch for potted plants in some very small gardens. This product's used extensively throughout most markets. The Hunter PLD, our professional landscape drip line, similar to others that are out there, it is pressure compensating. We do have the check valve. We have some standard flows. We also have reclaimed product in purple, the non-potable color, and in a 7-year warranty with the assorted fittings. All right, this is where it gets exciting for drip and for other products. When you have some densely planted areas, you can see the rows of these grasses. It's a perfect application to lay out some emitter line, is what the guys are doing here. Here's an example of one of those locations where they've staked it into the ground. They will mulch directly over that. Another area, it's a long bed next to the street. This is a perfect application to do an emitter line product. You could water this area with sprays, certainly, but this is an application where you have a few plants. It's not a turf bed, and you're trying to avoid having runoff, overspray, and therefore water waste. Here's a side picture of that. It's just a perfect application for an emitter line product. Similar here, this was a retrofit. If you look in the bottom right corner of that planter bed, you'll see a spray head that's been capped off. The emitter line is extended through there, and in this manner they were able to avoid some of the overspray that they currently had. the end product there. All right, there are different kinds of layouts you can do with emitter line. You don't necessarily need to use fittings. You know, the beauty of some of these products is they're flexible. You can go around corners, and you could certainly lay out something like this with a grid. However, I wanted to show you that you can also do what's called like a snake layout. And as long as you're covering the root zone areas of the plants, and you got that covered, then this type of layout is good. Have a flush valve at the end, and it's rock solid. Hedgerow, certainly this area, you wouldn't put spray heads in here, although we've both seen it done. But laying out some emitter line in 1 or 2 rows right here is needed as a perfect application to avoid overspray, runoff, and that sort of thing. Okay, standard on-grade drip. The beauty in this type of product on service is that it is easy to install. You can cut down labor expenses. It's relatively inexpensive. It's simple to repair. Once you lay out the product, stake it down and cover it with mulch. You can always find it. And you can see it running and inspect that as needed. Some of the issues are the water movement. You need to understand your soil. So in a finer soil, a clay soil, you'll want to use wider spacing. With the sandy soil, you need to know that the water is going to infiltrate the soil quicker, which I have a slide for. So understanding the soils is important with that. Vandalism can always be an issue with any irrigation product in a public place. And the appearance, on occasion, that drip tubing will pop up above the mulch. That's not so uncommon. So sometimes having appropriate stakes is a good thing. Also, this product, while it has been used subsurface, it's not as effective for subsurface applications as some other products, which we'll go into at this point. Okay. We offer an eco mat in a PLD ESD. This is the robust product for any subsurface applications. It's able to disperse all the water evenly, effectively, efficiently. Here is a product. Here's an installation for subsurface. There's some debate on subsurface drip irrigation under turf. The debates have been going on for quite some time, I would say decades. CIT has done studies. There's others that have done individual studies in different universities. This is actually an application that was installed about 10 years ago. Prior to our EcoMat or our products, but it was installed 10 years ago. Clearly, that this is successful at some level, and all those different grass beds that you see going through down the sidewalk have all been installed with this emitter line. This is one example how that has done. You can see the soil there. It's a pretty loamy soil, clay. With even spacing. One thing to note here is the precipitation rate. The application rate for 12-inch by 12-inch spacing is actually fairly high. So what Chris had shown you earlier is with our MP rotators, we actually have a 0.8 or 0.4 application rate. Here, even on drip irrigation, it's easy to assume that we have lower application rates because we have small flowing emitters. But as you lay out a grid, you need to understand that you can actually have a higher application rate. So keeping that in mind, you need to be aware of the soils and the run times associated with it. A traditional inline drip wetting pattern. This is just to show the wetting. Obviously, if that was in a like one of the beds I showed you with a few plants next to the street, this would work appropriately for above ground. If this was underground, you take into consideration the application rate and how long it will take for those wet spots to connect, and it's not necessarily the best application for subsurface. But this is a typical pattern for any standard emitter line that's laid out. All right, and here are two examples of soil and water infiltration. For a sandy soil on the left, you'll see that it percolates quickly. The water movement is fairly fast, and it goes straight down without quite as much horizontal movement. With the clay soil, you will see a lot more horizontal movement to the water and spreading, and it takes a lot more time for the water to infiltrate the soil as much as it would the sandy. So for this reason, if you're using emitter lines, you know, any company, Hunter or otherwise, will tell you that with a sandy soil, we definitely want to do 12-inch spacing to ensure that you have water meeting water between the emitters. On a clay soil, you don't need that. In fact, it's not going to be appropriate. So you're going to want 18-inch up to 24-inch spacing, perhaps. All right, what we offer for subsurface is called the EcoMat and the PLD ESD. The PLD ESD is a fleece-wrapped emitter line, and what this allows you to do is the emitter will drip and it will spread the water evenly throughout this fleece wrapping. That wrapping is also on our fleece mat, our EcoMat, attached to the EcoMat, and it extends that fleece out. And I'll show you a picture here. So the EcoMat, the way it works is you'll lay it out. It's 32 inches wide, so you'll lay out layers like a carpet on a floor. All right, you'll lay it out. The emitter line will pour the water out into the tube. It'll spread out throughout the mat, and it will have a water holding capacity of about 0.5 gallons per square yard. What this allows you to do is have a wonderful diffusion of water throughout the entire area. The efficiency is unmatched, and what it does is allows the roots to grow down to meet the mat, or sometimes grow through it, and it is an absolute great way to water subsurface, whether it's turf grass or under perennials or small shrubs. This is a good diagram to show what kind of depths you might use. So with turf grass, you might be anywhere from 4 inches to 6 inches deep. It encourages the deeper root growth. With smaller plantings and shrubs, you might be anywhere from 8 inches to 12 inches for optimal root depth. Some examples of this technology: public park in Germany. You'll see all the folks out here. They're running around, the kids playing in the turf grass. This may be watering right at that moment of the picture was taken. So it's a great feature of subsurface irrigation. On the right-hand side, you'll see a residence. I've got some young kids at home myself, and I can't put anything in our yard because we have overhead spray at this time. But when you have subsurface, you can have a beautiful yard. You can save water. You can prevent some overspray and water waste. And you can also have some of the kids' projects or a grill or whatever it might be on the surface. One thing to note too is just because you have drip doesn't mean you're saving. So I've noticed that I will see some installations and someone will install drip and set it to run for 4 hours when they need to run it for 1 hour, and it'll end up defeating the purpose. So understanding, once again, your soils and necessary runtime is important. Here's another photo, Office Park in La Jolla, where they set up some subsurface drip, some EcoMat, and they've got some lawn chairs. They never have to worry about the spray. This is a cool from start to finish construction. The native soil is removed. They left it with a 6-inch depth to be able to install the EcoMat, some soil on top, and put in the sod. These are some installation photos. Putting in some tacks or something to keep it down isn't necessary, but I recommend it. As you're pouring in soil and that sort of thing, it's possible to pull a lip up, so tacking some of it down is a good idea. and the finished product on the right. It's a great application for this in particular. You'll see the walkways in areas that we just don't want to overspray. You'll also see on the left picture there's a purple PVC sleeve. So we got two things going here. They're obviously using non-potable water, reclaimed. At the same time, it's PVC, so they've established a good structure for this. It's not flexible, so they have a good starting point for which to lay out the eco-mat. Filling it in, they'll need to compact that down just a little bit, and then they've got the finished product on the right. All right, a few more photos of some model home projects that we've installed here. Nice outcome on all of these. This is particularly difficult. You know, with the spray, as a drip guy, of course, I'm passionate about drip. I'm passionate about water conservation. But at the same time, there's those of us that do appreciate the overhead spray. We see it working. You know, there's different reasons and logics for using overhead spray or bubblers or drip. For this application, you know, the eco-mat was a perfect fit for it. And you don't have to worry about sprays or having them go on when a car is sitting in the driveway. Another home with the eco-mat project. This was installed fairly deep. We're going to install some plants here, which you'll see in a moment. Here we've got a photo on the left after 3 minutes of watering. You can see some of the wetting patterns, hopefully. After 15 minutes, the eco-mat is almost completely saturated. And so a typical watering time might be between 15 to 20 minutes for an eco-mat. Here we've got the plant selection ready to go in and the finished product. Beautiful installation here. All right, this is at the Apple corporate offices. We have some zones of eco-mat going in. This is just a teaser at this point, but if Chris wants to interject a little more info afterwards, he can do that. Okay, some challenges to subsurface irrigation. It will be additional labor and material cost. For startup, we need to typically dig and amend the soil. It's relatively new, and managing the soil moisture is important as well. So having soil consistencies, ensuring that we have similar compaction is something that should be considered. We do recommend soil moisture sensors. A fertigation system can be recommended with a lot of drip systems or irrigation, but with this, we definitely would recommend it. And sometimes, depending on the type of soil, you may want to install a temporary overhead. For example, with sandy soils, you know, the water is going to infiltrate the soil quicker. It is a little bit more difficult to wick the water in a sandier soil than with the clay. So understanding that in your soils is important. An example of that, a temporary overhead. At the Hunter site here, we do have eco-mat installed in front of this Hunter sign. If you look at the small plants behind, we actually have our PLD ESD subsurface underneath the plants in that zone. We established a temporary overhead system as this was installed in the summer. It was hot, and we wanted to ensure that the roots took and grew downward. And a benefit to subsurface of any kind is that you will typically have longer root growth, therefore healthier plants. And the soil doesn't get as impacted with that. With watering consistently and relatively less time in between waterings, you're going to encourage the healthier root growth, enable the oxygen in the soils, and have healthier plants overall. This is a similar photo to the EcoMat, the PLD ESD. When wanting to install a little bit more traditional emitter line underground, you would establish this like you would the brown emitter line without the fleece. Some cool applications for that. Flagstone. This takes a little additional work, but the overall effect after this install and design is real pretty. It's effective. Here's a photo with that. Certain driveways with this type of emitter line installed. This one takes a lot of work. If you got time and you got the right people to do this, this is an intriguing project. Some other small space areas very effectively controlled with drip irrigation. This side bed on the left, it's a beautiful outcome, but I would encourage anybody that's doing a project like this to run the emitter line lengthwise. This installer, this was a first-time project for him, and if he had ran the PLD ESD along the long ways, he would have had a lot fewer connections, a lot fewer cuts. His time would have been cut more than in half, and he would have had the same results. So this is a good how to do, but how not to do on this subsurface product. Similar applications that are perfect for subsurface emitter line. Rooftop gardens are great tight spaces for installing emitter line. Same as this, even with drought-tolerant plants, of course. Other areas. And now for green roofs, I'm going to switch back to Chris. Thank you.
And while they're switching there, I do have a good number of questions from you guys. We're gonna just letting you know we'll probably be running over 1 hour a little bit to get these questions answered, and also we have many people asking if this PowerPoint presentation will be available with the video for download, and I'm assuming that's going to be okay, but also I'll ask Chris. So we do have a lot of people wanting to know if the PowerPoint presentation will be available with the video. So we're hoping.
Yeah, there'll be a PDF available for you.
Fantastic. All right. Well, I'll let you get right to it, and then have about 6 questions lined up for you.
Okay, well, this was going to be kind of a teaser into green roofs anyway. There is so much that goes into irrigating green roofs. They're so different, and the structure of a green roof is different. But there's all these different reasons now that we want to do green roofs for LEED buildings and heat mitigation. Obviously visual appeal. It's attractive space. It gets a lot more complex because you have so many different layers of the roof, and where do you put the irrigation in, and how much soil are you going to get? Is it going to be an extensive roof or an intensive roof? And if depending on those, that might determine whether you're going to go with an overhead system, or if you're going to go with an in-ground system, like an EcoMat. And like Rob said, the fleece fabric is great for green roofs because you have very porous soils. Typically, it's an engineered soil, really lightweight soil, and it's hard to get that water to move across it if you're doing drip. But other things with green roofs, I'm going to kind of skate through this real quick. But you got to figure out what your power supply is because you're up on a roof. Are you going to run 2-wire decoder system all the way up to the top floor from the ground, or are you going to use a battery-powered controller, something solar-powered? Then are you going to go overhead? Are you going to with an MP rotator or a rotor? Or are you going to go micro sprays? Or are you going to go with subsurface like an EcoMat or the PLD ESD on some of your narrow areas? And of course then controlling it, that low flow valve is a very good comment. You need the drip kit, and then obviously recommend if you can do some sort of a soil moisture sensor or something to be able to kind of control so you don't over irrigate your roofs. There's a few just quick examples. This is an overhead system, the County Operations Center down in San Diego. They went with an overhead irrigation system, MP rotator. Pretty easy because there's really not a lot of wind drift with an MP rotator. Kind of gets the water to the target. This is another green roof. This is not an example of a small space. This is a pretty large green roof. In this particular case, they ended up going with an EcoMat. It was an acre and a half of EcoMat used on a green roof, and again, you'll see that they're putting the soil down, putting the mat down over the top, tacking that down. You don't want to tack it too far because you don't want to hit the waterproof membrane, of course, because you're dealing with a green roof, and then of course bringing the soil in over the top. So we did have some other guides because I know we're kind of running a little bit short on time. Hunter does have some resources online, our drip design guide, the MP rotator design guide for the short radius MP 800 SR, as well as a green roof design guide, which goes much more in depth than what we just kind of touched on with some of the slides. So that being the case, there's other great industry resources. You can click on these as well. I don't know if it'll come up on your video, but good resources through ASLA, and of course, if you're in California, take a look at AB 1881. And so, yeah, let's go ahead and take any questions that we have time for, Jeremiah, and kind of go from there.
Okay. All right, yeah, we got a good number of questions on the EcoMat, quite a bit of interest in that product. A couple people wondering, for instance, can you drive over it? I assume with that driveway, the Hollywood driveway, you can. But relatedly, how long will it last? Are there any maintenance issues? If the roots do grow through it, does it harm the integrity of it, and so on? All the kind of typical subsurface problems, concerns, basically, with that apply to it.
Yeah, exactly. Those are good questions. Just like with any type of an installation here, I'm going to swap my screen, sorry, on this. Can you see that now? Going back to some of the subsurface challenges, these are a lot of the questions that get brought up. If you compact the soil over the top of it, it's just going to be like any other installation. If you drive over turf, you can compact it. Again, we're watering from below, so a compacted turf, the water's going into the root zone and actually kind of coming up into the soil. So it's it's one of those things where I wouldn't recommend driving over turf in general, but you don't have to worry about compacted soil with water sitting on top trying to make its way through. You're still going to get that in there, but it's not good agronomic practice to have heavy compaction. And Rob mentioned a 4 to 6 inch root depth. I recommend if you can do a 6-inch root depth, that way you have access to still aerate your soil if in fact you need to. So there are some maintenance challenges with regard to this stuff, because anytime we're going subsurface, it's a whole nother, like you said, consistent series of questions regardless of what manufacturer and what type of product. You want to make sure you've got your fertigation systems in there. This slide here was taken from an interview I did with a very large national maintenance contractor, specifically about these subsurface systems that have been installed for almost a decade, and what their experience has been on them. So while it's still a relatively new concept for a lot of the maintenance contractors, they're getting it. It's there. It's just about I think us continuing to leverage the technology where it's appropriate. Was there something I missed out of that question?
I think just is there an estimate on the lifespan of it?
Oh, we manufacture the EcoMat for at least a 25-year life. It's a polypropylene fleece material, so it's designed to last for decades. It is recyclable, but it's not going to degenerate in your soil. It's designed to last a long time. And if the roots grow into it, I think that was another question. If the roots grow into it, it's perfectly fine. In fact, that one slide you saw with the big, thick root zone, you're going to see the roots grow into it. And I think, where was that slide? Was it? Anyway, you're going to see the roots grow into the mat. It's very common because that's where the water source is, and of course the water is going to wick throughout the soil with the capillary action. But you're going to have, if you deficit irrigate and you go a long time between irrigations, you might have the roots going onto the mat, and that's perfectly fine. It's one big wetted area instead of having a lot of the roots attracted to the wet spot where the emitter is. The fleece distributes that water pretty quickly, so it's a nice even wetted pattern.
Great. And then we had a couple of other questions back to the above grade emitters. We have, we're wondering, Chris was wondering if you have a multi-port drip emitter. And actually, two questions that he asked, both multi-port drip emitter and then also something similar to the Rainbird Zero Pops.
Yeah, currently we don't have a multi-port, for the quarter-inch distribution tubing. Is that what you're looking for? I think that's what he's asking. We don't have one currently. We're kind of expanding our drip offering. We started with products that were considerably different than what the market had. And as we get into the quarter-inch distribution tubing, kind of going backwards to what we were doing a lot in the 90s, you will see some sort of a distribution device like that. And as far as the ZeriPop, no, we don't have a product like that. But stay tuned. There's a lot more to come. Rob is diligently working on new innovations. So.
Sure. And then one last question. If you could bring up the slide on the valve kit again. We had a couple of people wanting to see the valve information again, and particularly Chris with the sharp eyes here. He said, noticed that your slide said it was a 0.5 GPM minimum, but the website says a 0.1, and so he was hoping to get a little clarification on that.
Yeah, on the actual drip zone kit, that's a good call on that. The drip zone kit may be a 0.1. I'm trying to remember where that slide is here. The website may call out for a 1 gallon per minute on the drip zone kit. However, the valve itself, the ICV valve that we're referring to, is a 0.5, I believe. Gallon per minute on the valve itself. So when we were referring to these bubbler systems here, you may not have a filter on there. Here it is right here. Sorry about that. Yeah, and then you might find on the ICV itself, on the drip zone kit, I believe it is well, I'm seeing it called out, looking at the catalog, as a 0.5 to 15 gallon per minute on the drip zone emitter, or drip zone kit, which would be the IC, the PCZ and the ICZ. Let's see.
Gotcha.
Here.
And that was my thought too. Is the kit. That's the additional flow to push through the filter there.
Yeah. We do also have a double barrel kit too, which is 1.5 inches, and that's also going to be a minimum. And our 1.5 inch drip zone kit is going to be a 20 gallon a minute to a 60 gallon a minute. But yeah, once you get through that pressure regulator and the filter, you start adding on, friction after the valve, and so you are going to need a higher flow rate for the actual drip zone kit. I think he's correct on that.
Okay. Well, and so that pretty much rounds up the questions. And, just as you and I were talking earlier this week, the interest level in subsurface irrigation really is, the vast majority of these questions were regarding that. So I would like to tell the room full of attendees here that, we were talking about having Hunter present here a subsurface irrigation webinar early next year. So I think we can all look forward to that. And I think that's pretty much all I have. If you have any closing comments here.
Well, we'd just like to thank everybody for their time, and certainly, remind everybody that there are a variety of solutions, and you really want to look at your site and each project in individual as to what's going to be the the routine maintenance down the road, what's going to give the plants the best chance to live, and how can we irrigate these things efficiently, given the different options and tools we've given you today. So thank you guys for irrigating responsibly and using water wisely. And if there's any other questions that you may have, please feel free to reach out to Rob or myself or your local Hunter representative. Thanks again for the time, Jeremiah.
You bet. All right. Bye, everybody. Happy